Till now, in the previous examples, we have seen cases where n jobs need to be processed on m machines, where the sequence or the order of processing on the machines is constant or the same. So, for example, each job would be processed on, say, M1 first, then M2, and then M3. In this example, we will see how to process different jobs on the same set of machines but in different orders. So for example, the first job is to be processed on M2 first, then M3, and then M1, and the second job is to be processed first on M3, then M1, and then M2. So let us look at this example. You have a party at your house. You want to prepare 2 Thai dishes using 6 different pieces of equipment, such as a microwave, grill, pressure cooker, frying pan, strainer, and a knife. The order in which these are used is different for the 2 dishes as shown in the table. Find the optimal cooking time for the 2 dishes to be cooked simultaneously. Assume that 1 unit each of the 6 pieces of equipment is available. So as shown in this table, for dish 1 we have equipment sequence as M, G, P, F, S, and K. Here M I have used as the first letter of the equipment, that is microwave is M, then G is grill, P is pressure cooker, F is frying pan, S is strainer, and K is knife. So for dish 1 we need 2 hours to process on microwave, 3 to process on the grill, 1 to process on the pressure cooker, and so on. Now dish 2 is to be processed first on the strainer, then on the pressure cooker, then on the not on the knife, but we have to use the knife, then on the frying pan, and so on. And the duration for each of these equipment is also given. So 1 hour we need for the strainer, 4 hours we need for the pressure cooker, and so on. Now, to reduce the overall time, we would wish to process both these jobs simultaneously. However, let's see what happens if we try to process both these jobs simultaneously. So first, dish 1 needs 2 hours to process on the microwave. At that time, dish 2 needs a strainer, so definitely there is no clash. After the second hour, then dish 1 needs to be processed on the grill, and after the first hour, dish 2 needs to be processed on the pressure cooker. So again there is no clash, so till the 5th hour here and till the 5th hour here there is no clash. After the 5th hour, dish 1 needs to be processed on the pressure cooker, which needs 1 hour, and dish 2 needs a knife, which needs 2 hours. So here till the end of 6 hours there is no clash. Here till the 7th hour there is no clash. Now after the 6th hour, dish 1 needs a frying pan, and after the 7th hour, dish 2 needs a frying pan. So here we have a clash, because from the 6th hour onwards till the 10th hour, dish 1 needs to be processed on the frying pan, and from the 7th hour till the 12th hour we need the frying pan for dish 2. So in this case we'll have to prioritize which one to be processed, and let's see how this situation can be resolved using the Akers graphical method. As shown in the graph, we plot dish 1 along the x-axis and dish 2 along the y-axis. We have also shown the sequences and time requirements of the equipment used for making the two dishes along the X and Y axis. For dish 1, the first equipment required is M, which is required for 2 hours. The next required is G, which is required for 3 hours, and so on. Similarly, on the y-axis, equipment S is required for 1 hour, equipment P is required for 4 hours, and so on. Next, we make rectangles on the graph to represent areas showing the overlapping of the requirement of the same equipment by the two dishes. For example, on the x-axis, the first equipment shown is M, which is for 2 hours. So we make a rectangle corresponding to the 3 hours requirement of M along the y-axis. So this is M here, this is for 2 hours, and this is M here, which is here for 3 hours. So we make a rectangle here. Next, let's take G. So G is here for 3 hours, and here G is for these 5 hours. So we'll make a rectangle for this area, that is G for 5 hours and then G for 3 hours. Similarly, for P, on the x-axis it is 1 hour, and on y-axis it is 4 hours. So let's make the rectangle. 1 hour on X and 4 on Y. Similarly, for F, we have 1, 2, 3, 4. 4 hours on the x-axis, and 1, 2, 3, 4, and 5 hours on the y-axis. So let's draw the rectangle. Similarly, for S, 2 hours on the x-axis and 1 on the y-axis. So we'll draw the rectangle. For K, 1, 2, 3, 4, 5 hours on the x-axis and 1, 2 hours on the y-axis. So now we have made all the rectangles for these equipment for the overlapping times. Let me shade these rectangles for ease of recognition. Now, starting from the origin, which is this here, we have to make a line at 45-degree angle. This line represents the two dishes being made simultaneously using different equipment. Whenever this line comes across a rectangle, a horizontal or vertical movement is made in order to avoid crossing the rectangle. So the rectangle represents that you are using the same equipment for both the dishes, which we want to avoid. And the line at 45-degree angle represents that the two dishes are being made simultaneously using different equipment. The horizontal movement would mean that dish 1 is being prepared while dish 2 is waiting. A vertical movement means dish 2 is being prepared while dish 1 is waiting. We have to always try to use 45-degree line as much as possible, as it results in the simultaneous preparation of the two dishes, saving on overall time. So let's start drawing the 45-degree line. So we are starting from the origin, that is here, and we just crossed this rectangle and we hit the rectangle for equipment F. So at this point we have a requirement of using equipment F for both dish 1 and dish 2. Now we can't cross this equipment, so we have to move horizontally, that is dish 1 will be prepared while dish 2 is waiting. So from this point here we will move horizontally, that is we'll continue with dish 1 while dish 2 is waiting. Now once we reach this point, that is the edge of the rectangle, we have two options. First is to move vertically, that is move along this line here. Second is to start moving at 45-degree angle again, that is continue like this. So let's draw first the 45-degree angle line. So we move on at 45 degrees angle, and here we have to stop because this is where dish 1 is completing, that is the 17th hour. So we stop here, but dish 2 is not yet complete. So once we reach here, then we have to start moving vertically, and we will have to move till we finish dish 2, which is end point of G. So this means that we are processing only dish 2 at this point. So here at the edge of the rectangle for equipment F, we had two options. One is to draw a 45-degree angle line, or to move vertically along the rectangle. So let's try the second option. So here I'll draw a line vertically along the rectangle. Now at this edge, then we have to go 45-degree angle again. So I'll draw a dotted line to denote the second path. So we'll have a line something like this. And then after reaching this edge here, because we have completed dish 1 at the 17th hour, then we have to go vertically up. So we will have the same line and overlap. Now the simple way to measure the overall duration of a path from the graph is to first take the total horizontal distance covered. So in this case we have 17 as the maximum horizontal distance. So 17, and then add to it the total vertical distance covered by a path. So the first path, which goes like this here, and then the horizontal for the rectangle for F, and then it goes 45 degree again, and then a vertical line. So for this, the horizontal distance, let's see, so first horizontal distance is 17, and then add to it the vertical distance covered. So vertical is 1 2 3 4 5 6 and 7. So 17 plus 7, which is equal to 24. The second path, which again starts from the origin, goes at 45 degrees angle, and then goes horizontal along the rectangle for F, then goes vertical, then again at 45 degree angle, and then vertical again. So for this also we have the horizontal distance as 17, and let's add the vertical distance. So vertical distance is 1 2 3 4 5. So 17 plus 5, and then it travels vertical again here, so 1 and 2. So 17 plus 5 plus 2, this is also equal to 24. So basically we get the same overall time for both these paths. So basically, once you understand the concept here, you don't need to plot a graph every time. So the main concept here is that what we are doing is, till the time we hit a point where there is an overlap of an individual equipment for the two dishes, we are processing both the dishes in parallel. Once we hit a point where we have a clash in the equipment, then we process one dish and we are putting the other dish on hold. And as soon as both the dishes are done with that equipment, then we again start processing both the jobs or both the dishes in parallel. This will help reducing the overall processing time for such jobs.